Now the magic of leaderless replication is in quorums. Let me explain the formulas that we use in quorum. Consider n as the number of nodes that are number of replicas. Then w as the number of nodes that must acknowledge the writes in a quorum. Then r is the number of nodes that must respond to the reads in a quorum. So the formula is w plus r is greater than n. If we follow this formula, we give the consistency, we give the high consistency, we make sure that we have the latest data that we are writing to, we read from the latest data that we are reading from. Let me give an example. So here there are 5 servers. So for example, if a write request has come to this one, we want to write some value. So it will go to server 1, server 2 and server 3. After we have got the response from 3 servers, then it is considered as successful. Similarly, if a read comes, then it makes sure that at least 3 servers responds to the read request. Then only the read is successful and it takes the maximum or the latest version of the value. So according to the formula, here we see we have w is equal to 3 and r is equal to 3. So w plus r is 6, which is greater than 5, the number of nodes. So this is following the formula, or this supports the quorum formula. Now, if you write to 3 nodes and read from 3 nodes, at least one node appears in both the sets. So, for example, we are writing to node number n1, n2, then n. We are writing to n1, n2, and n3. Similarly, we are reading from n2, n4, and n5. So if you see, there is an intersection of the node. So this formula makes sure that there is an intersection between the number of writes we are doing and the number of reads we are doing. So that is why we make sure that we have the latest value, and this is how it happens. So for example, if we do writes to 2 nodes and we read from 4 nodes, that is a must for us. In this case also, w plus r is equal to 6, which is still greater than 5 and follows the rule of the quorum. In that way also, we are making sure that we are having the latest value. Usually this configuration, the configuration 2, is primarily used if we want faster writes and we are okay with the slower reads. Now let's take another configuration where we do w is equal to 1 and r is equal to 1. You see that the sum is lesser than equal to 5. Now this does not follows the quorum formula, which was w plus r should be greater than n. Now because of this, it does not guarantees consistency. Usually we use this configuration if we are okay with eventual consistency and we do not want a strong consistency. Let me show you some of the configuration. Now if we want a strong consistency, we will do equal number of writes and reads. That is, if the number of servers are 5, then we will make writes equal to 3 and read is equal to 3. This way it is balanced and we have a very strong consistency. We can use this in banks and other high consistent application. But if our application is a very write heavy application, so what we can do is we can reduce the nodes we write to and we can increase the reads we are going to do from. So in this case, if you see, we have reduced it to 2 and we have increased the reads to 4. So still it is equal to 6. So 6 is greater than 5. So fast writes and slower reads. Now if we want an application which is read heavy, such as in the case of social media, we are reading a lot than writing. So what we can do is we can reduce the number of read nodes as compared to the write node. We can increase the number of write nodes. So we make sure that the data written is consistent, but we want faster read. So that is why we have reduced the number of reads. Now for eventual consistency, we can make 1 to write and 1 to read. Although the sum is 2, which is not equal to the formula, which does not satisfy the formula of the quorum, but we still use it some places because we are okay with eventual consistency. Now here's what candidate miss. The formula W plus R greater than N guarantees you'll read the latest write, but it doesn't mean you'll never see the old data. Let's look at one of the edge case. Now for t is equal to 0, client A writes v1 to server n1, n2 and n3. So at the same time, at t is equal to 1, before the replication completes, client B reads from n4, n5 and n1. You see what's happening now. The replication hasn't yet completed. It means that at n4 and n5 the value hasn't yet reached, but at n1 the value has reached. So if n4 and n5 haven't received the value v1 yet, but n1 has, so client B gets v1 from n1, v0 from n4 and v0 from n5. In this case, the client picks the higher version. That is, it uses the latest version. So it will use the value from server n1. This is how we solve the problem of non-replication if the data is not yet replicated. That is why version numbers are critical. For a leaderless system with n replicas, I'd configure quorum as W plus R is greater than N to ensure the consistency. For example, with 5 replicas, W is equal to 3 and R is equal to 3. This guarantees that there is an overlap for at least one node in the read set and will have at least the latest write set. The trade-off is latency. We are waiting for 3 nodes instead of 1. For read-heavy workloads, I might choose W is equal to 4 and read is equal to 2 to optimize the